In this video, I am going to explain about the secure host onboarding in enterprise network. Actually, it means that how we can add our devices, our host to the enterprise network securely. Host onboarding, as the name suggests, is the process of onboarding the clients in a network, which could include workstations, users, BYOD devices, IoT devices, IP phones, cameras, network devices such as access points, and so on. Actually, I'm going to focus on the security aspects of onboarding the hosts in the network in a flexible way with minimal disruption to the network or the client. Actually, you know that maybe you heard about the zero trust networks. Cisco Zero Trust is a security model based on the principle of maintaining a strict access control and not trusting anyone by default. Okay, not trusting anyone by default, even those already inside the network perimeter. Network access control is a security requirement in any IT network. And Cisco ISE plays a key role in making sure the endpoint connecting into the network is authenticated and given proper authorization based on the endpoint and its role. This is implemented using 802.1x, which is a port-based authentication that restricts unauthorized clients from connecting to a LAN through publicly accessible ports. As you can see here, we have authenticators and also authentication server and the supplicants. They are the components of 802.1x architecture. It means that an authentication server validates each client, means supplicants, connected to a network access device or authenticator. As you can see here, supplicant connected to the port of the authenticator, and authenticator can take help from the authentication server to authenticate the supplicants. It means that an authentication server validates each client or supplicant connected to a network access device authenticator port before making available any services offered by the switch or the LAN. Here you can see before 802.1x authentication, we have restricted connectivity, restricted usage of switch port, but after 802.1x authentication, we have complete or full switch port functionalities. An 802.1x enabled port goes to an authorized state after being successfully authorized by the authentication server. If the authentication server is unable to authorize the client, the port goes to an unauthorized state. And the 802.1x port's host mode determines whether more than one client can be authenticated on the port and how authentication is enforced by the switch. Let me to explain about the different host modes that are available in 802.1x. The first mode is single host mode. You can configure it with authentication host mode single host in the switch port. Let me to show you. Here we can use authentication host mode and then single host. Okay, single host means single host mode. What does it mean? It means in a single host mode, only one MAC address is allowed on the switch port. And the switch authenticates the port and places it in an authorized state. Detection of a second MAC address on the port result in a security violation, as you can see here. Okay, single host mode is mainly used in environments that have a strict restriction of connecting only one client per port. The second mode is multi-host mode, and you can configure it with authentication host mode multi-host. Let me to show you in our CLI authentication, again host mode, and after that we have this option multi-host, means multiple host mode. What does it mean? In multi-host mode, the first MAC address attached is authenticated. and subsequent hosts that are attached to the port bypass authentication and piggyback on the first MAC address's authentication. As you can see here, authenticated, and this is piggybacked MAC address. And multi-host mode on the port along with port security can be used to manage network access for all the MAC addresses on a port. The next mode is multi-domain mode, and you can configure it with authentication host mode multi-domain. Here you can see authentication host mode and then multi-domain or multiple domain mode. What does it mean? Multi-domain mode refers to two domains, data and voice. In multi-domain mode, also known as multi-domain authentication or MDA, an IP phone and a host connected behind the phone are authenticated independently. As you can see, this is the IP phone and the endpoint behind the IP phone. Okay, even though they are connected to the same port, the IP phone is placed in the voice VLAN and the host is placed in the data VLAN as per the policies pushed by the authentication server. Any second MAC address, like the MAC address of endpoint 2, detected on the data or voice domain result in a security violation. And the last mode is multi-authentication mode. You can see the command that we need to configure it, authentication host mode multi-auth, and here you can see this command, the authentication host mode multi-auth or multiple authentication mode. Okay, what does it mean? As you can see in this figure, in multi-authentication mode, one client is allowed on the voice domain and multiple authenticated clients are allowed on the data VLAN. Cisco DNA Center by default provisions multi-authentication mode on all the 802.1x enabled ports. Okay, in Cisco DNA Center, the default mode is this mode. And multi-authentication mode is the most commonly used host mode, as it ensures that every client is authenticated before connecting into the network. But let me to emphasize that in multi-authentication mode, only one VLAN needs to be enabled for all the hosts connected to the port. You cannot have two data hosts connected with different data VLANs assigned by the authentication server. Alright, now we know about the actually different modes that we have in 802.1x for one interface, for one switch port. Alright, in this figure we can see 802.1x enabled port flowchart. I want to explain about it. As you can see, endpoint connected to the port. After 802.1x process, authentication occur, and if it is successfully finished, you will be authorized to access to the network. Actually, the port will authorize, and if no, the port will be remain in unauthorized state. You know that the network administrator would be happy to switch over to port authentication within a day, but 802.1x involves client configuration, authentication server configuration, and also network device configuration. For example, an employee tried to connect to the port where 802.1x is implemented, okay, and his or her laptop supplicant was not enabled, okay, and the employee doesn't know, okay, that he is able to connect after enabling 802.1x. This generates a service ticket to the operation team, who is now bombarded with 802.1x issues. A phased approach is necessary when a solution involving multiple components is involved. Okay, the phased approach initially needs to be placed in a monitor or audit mode to gain visibility into the environment that's being handled, and after continuous monitoring, the solution can be moved toward an enforcement mode. Okay, because of that, we will learn about the phased approach. Now we know why we need a phased approach, but before talking about this phased approach, you know that if a network currently does not have the port authentication any client connected to the port is given some level of access depending on the port configuration, such as the VLAN configured on the port. However, the goal is to move toward a secure network, which means enabling port authentication. If 802.1x port authentication is enabled on all the ports overnight, the expectation is that every client coming into the network should have a successful 802.1x authentication. Okay, as indicated in this flowchart, when an endpoint is connected to the 802.1x enabled port, if the authentication fails, the client is in an unauthorized state, which is the goal here, the phased approach. All right. Here we have two phases. Actually, the 802.1x deployment model recommendation is to follow a phased approach, and there are two phases in this approach. Phase 1, monitor mode or visibility mode. Actually, the 802.1x deployment model recommendation is to start with monitor mode. In monitor mode, the port status is open authenticated, in which traffic is allowed from the authentication status. It means that all traffic will allowed. Look at here, before authentication, all traffic allowed, and also after authentication. It means that it is not related to authentication. And it means that here, without authentication, all traffic will can pass. Why? Because this is monitor mode. Okay, actually this figure depicts traffic on the network port placed in open authentication as part of the monitor mode. Before authentication and after authentication, all traffic is permitted. Even when the user fails authentication, the user is able to access the file server and the rest of the resources available on the network. Here you can see we have a user, it can pass or it can fail after authentication, but the ports open unconditionally. It can reach to the file servers. But as you can see, the information from Cisco ISE in monitor mode will be sent to the monitoring, or to the, for example, the platform that you have for monitoring. Monitor mode does not have an effect on the end user's access, which makes it seamless, and the administrator can gain visibility into the endpoint's authentication status without disrupting the endpoint access. How we can enable it? Here you can see the commands. Interface gigabit 101, switch port access VLAN 100, means this port is the member of VLAN 100, then switch port mode access. Switch port voice VLAN 101, authentication host mode, multi-authentication. I actually explained about it. This is the default behavior also. And the command that we need, authentication open, means please enable monitor mode. That's it. And after that, MAB if you want to have MAC authentication bypass on the port, and .1x PAE authentication enables 802.1x. Starting with monitor mode has multiple benefits. This mode provides visibility into the types of devices connecting to the network. It also lists users who successfully authenticate, that is, present valid credential, and users who fail authentication, that it is present the invalid credentials. Network administrators can see all this information in ISE authentication reports and summary reports of past and failed authentications. And network administrators use this phase to gain visibility, evaluate remaining risk, and prepare for network access control by working on the failures reasons reported by ISE for the user who failed authentication. Let me to configure one port. Okay, for example, the ETH00. The first command is switch port access, for example, VLAN 100, and also switch port mode access, and also switch port voice VLAN 101. You know that we use multi-authentication host mode. Because of that, the command is authentication host mode and then multi-authentication. After that, authentication is open. This is the command necessary for monitoring mode. And after that, the authentication port control auto. And if you want to have MAB or MAC authentication bypass, you can use MAB. And finally, with this command, .1x PAE authenticator, we can enable the .funx on this port. .funx PAE authenticator. That's it. And it means that one of the here, as you can see, one of the failure reasons could be that the supplicant is not configured correctly. Okay, the administrator can work with the endpoint management team to configure the supplicant correctly, installing the appropriate certificate or credentials. This is continuous. This is a continuous actually learning phase, as the change made by the administrator based on the observations should result in increasing the overall authentication success percentage in the network. Okay, network operators or administrators typically spend a much longer time in phase 1 than in phase 2 to make sure the effect of 802.1x enablement are minimal to the end clients. Alright, now let me to explain about the phase 2 or low impact mode. Actually, phase 2 has two modes, okay? Low impact mode and also closed mode. Some customers opt for low impact mode as the end goal, whereas customers in sectors such as federal governments or banking typically opt to move toward closed mode. Okay, which mode to be finally placed in completely depend on the enterprise security and business requirements. Compared to monitor mode, low impact mode incrementally increases the security level of the network by configuring an ingress port ACL on top of monitor mode at the port level. In low impact mode, security is added to the framework that was built on monitor mode by applying an ACL to the switch port, okay, allowing very limited network access prior to authentication. After user or devices have successfully authenticated, they are granted full access or full actually network access. As you can see here, before authentication, okay, the user only has limited connectivity, okay, and that's actually about DHCP, TFTP, EAPOL, but it cannot use the end device cannot use HTTP. But after authentication, as you can see, all of these protocols are permitted. Okay, this is pre-authentication ACL permit EAP, DHCP, and also, for example, we have DNS deny any. And after authentication, after permit ACL, we have access to the file servers. Okay, this is the low impact mode. The ACL is configured statically on the access port and provides basic connectivity for guests, contractors, and unauthenticated hosts while selectively limiting access, thereby introducing a higher level of security. The level of access given to the endpoint can be differentiated based on successful authentication and authorization by pushing a downloadable ACL or DACL, okay, from the Cisco ISE. Actually, after authentication, according to the user authenticate, Cisco ISE will send DACL or downloadable ACL to the edge device, and it means that different users will have different different authorization actually level. And DACLs or downloadable ACLs are configured in ISE depending on the corporate security and business intent. DACLs override the ACL configured statically on the switch port. Here you can see the configuration. For example, on the gigabit 1.4 switch port access, switch port mode, switch port voice VLAN, IP access group pre-authentication in. Okay, this is the access group, access list actually we configured previously. And after authentication, Cisco ISE will send us to this actually edge node, the ACL, and that ACL override the static ACL. Okay, as an example of how this feature may be used is to enable any device attaching to the network to use DHCP, DNS, and Active Directory, and perhaps get to the internet while blocking the device's access to internal resources. When a device connected to that same switch port passes authentication, a DACL is applied by ISE that permits all traffic. This mode continues to use open authentication on the switch port while providing strong levels of security for non-authenticated users. Okay. However, because a limited set of traffic always flows regardless of the authentication state of the device, this mode becomes ideal for today's enterprise by allowing regular IT operation activities to occur, such as reimaging workstations with, for example, PXE or pre-boot execution environment solutions. The purpose of the statically configured ACL in low impact mode is to allow critical traffic to flow prior to authentication. It may be necessary to open additional traffic depending on the environment, such as to allow access to remediation systems. Okay, after users or devices successfully authenticate, they are granted full access network with the DACL that permits all traffic. This is critical component of this phase of TrustSec deployment. I will explain about the next phase 2 mode or other condition that we can experience closed mode in the next section. But here, let me to add our configuration. We can configure this command IP access group and other commands on the ETH01. But also, if you want, you can add only the IP, because we configured ETH00 previously. Show run. And then for the interface ETH00, we have the previous configuration here. Okay, only we need to add IP access group and the name of your ACL, for example, the ACL1, and after that inbound direction. Actually, this is the pre-authenticate or pre-authentication access control list, and it means that I want to implement low impact mode. Now let me to explain about the other condition that we can experience in phase 2 closed mode. About the phase 2 in closed mode, you know that closed mode is one of the end goals as part of the phase deployment model of 802.1x. In a properly prepared network, closed mode provides total control over switch level network access. This type of deployment is recommended only for environment in which administrators are experienced with 802.1x deployments and have considered all the features that go along with it. This mode can also be described as deploy with caution mode. Okay, in closed mode, as you can see here, okay, the left figure, the switch port does not allow any traffic except EAPOL or Extensible Authentication Protocol over LAN until a successful authentication takes place. Traffic such as DHCP, HTTP, DNS is not permitted while authentication is in progress, but after authentication, all traffic will be permitted. Closed mode can be useful for VLAN-based enforcement because the client does not get an IP address until it has been successfully authenticated. And closed mode is perfect for Cisco SD access deployment because no default VLAN is assigned at the port level. To add more granular access control, you can configure Cisco ICE, okay, to do dynamic VLAN assignment and push scalable group tags, SGTs, I will explain about them, to restrict or permit traffic between different groups. By isolating traffic from different classes of users into separate VLANs and also scalable group tags, closed mode provides the foundation for virtualized network device services. And devices that cannot authenticate or fail to authenticate retain the same level of access that they had before authentication. In other words, they have no access to the network because in closed mode, denying access is more desirable than providing limited or guest access. Actually, here you can see that before authentication, we have only EAP access. And after authentication, we have complete access. And this example shows the 802.1x port configured in closed mode. First, we need to remove authentication open from monitor mode, and after that, the port will put in closed mode. As you can see, no pre-authentication ACL is applied at the port level like the low impact mode. Okay, let me to configure it. Here now, first I'm going to remove the ACL on this port, and after that the next command is no authentication open, and you know that we need to use this command authentication periodic, and after that authentication, for example, timer re-authenticate, okay, re-authenticate server. That's it. And we have other commands also. Deploying closed mode with VLAN assignment can have a significant impact on network architecture. Understanding these potential impacts is essential to a successful deployment of this mode. Therefore, the deployment of closed mode requires strategic planning and a variety of considerations. And the beauty of using closed mode in a Cisco SD Access world is that all the Fabric Edge nodes have the same VLAN database. They all support dynamic VLAN assignment, and Cisco DNA Center automates the configuration needed for the 802.1x actually phased approach. Because of that, at the end of this video, now we know that we use 802.1x in Cisco SD Access for authentication and also for authorization of users and devices.